Today's a really nice weather day and I'm going to try to light my house on fire. So this is just like the most basic intro to electronics for sort of survey of technology for my students. So we're talking about Ohm's law, which is a relationship between three aspects of electricity, but I want to explain what those aspects are first. So the three aspects that we're going to talk about are voltage, current, and resistance. So voltage is like water pressure. It's how much force the electricity is being pushed through whatever, the wire, air if it's like a lightning bolt, or wherever the electricity is passing through, voltage is the force that gets it through. So the second thing, current, is the quantity of electricity. So if you think of it with the water analogy that a lot of people use, it's like how much water is getting through, how much electricity is getting through. So voltage is the force, current is the amount of electricity, and then the third thing is resistance, which is nice because it's actually a word that makes sense in most people's mindset. So yeah, resistance is just whatever is opposing the electrical flow. So some things are really good at conducting electricity, like metal. Some things are really bad at conducting electricity, like air, or different types of rubber that's used as insulator to prevent electricity from flowing through it. So Ohm's law says there's relationship with where voltage is equal to the current multiplied by the resistance. Now, if we do a bit of rearrangement with that formula, we can also say that current equals voltage divided by the resistance. So let me explain what I'm going to set up here and kind of how it's all going to work. So here we have my house. It's a bit old, a bit of a bat problem. Here you can see the electrical work going through the walls. So for the circuit, I'm going to use a 12 volt battery, and the circuit itself has a 20 ohm resistance. So again, voltage is the force, resistance is trying to prevent that electrical flow. So the amount of circuit current that's going through it should be about 0.6 amps, which is a decent amount of electricity. And why I have in the middle of the circuit that grayish lump is something called steel wool. Now, theoretically, steel wool, because it's so thin, it will have the electricity go through it, it'll heat up, and it'll get hot enough to start the little house cardboard thing on fire. So let's see how that goes. Oh yeah, don't try this at home. Like, absolutely do not try this at home. This is not like a joke part of the video. This is legitimate. Do not try this at home. Please do not try this at home. Okay, so that didn't work. I had a couple of theories. I tested a few theories. Part of it was maybe there wasn't enough current going through it. That could be one thing. I did bring the battery back that I had that said it was a 12 volt battery. I checked it on a meter. The meter said 8 volts. So I don't believe labels anymore, and I have trust issues with them. So now that we know that that didn't work, after a few more tests, it actually came down to more of a chemical problem. The lump of steel wool was actually compacted too tight, so it was not actually going to ignite because it was basically smothering any sparks that were happening. But here's what it kind of looks like when you go directly to it with the battery. So the concept of having the weakest part of the circuit somewhere that you can get to is actually really big, because if it wasn't, it would be somewhere in your wall. So although my little demo didn't exactly work, if it was your house and the weakest part of your circuit was in the wall, one of two things could happen. You could just lose the circuit and then you wouldn't have any idea where it was broken, and someone would have to probably take a wall down or rip a wall apart, at least to some degree, to find and fix that problem spot. Now, if it's somewhere where we know where it is, such as a fuse box or a circuit breaker box, when too much current goes through the circuit rather than starting on fire, it just breaks that specific spot and you know where to go to. So some things that you might see depending on how it's set up where you live, there's these like old school fuses. They look kind of like a light bulb. So this was designed, this says 30 amp, This was designed to be the weakest part of a circuit. Now you don't want to cheat this, because if you try to put in something that's a higher rating, then the weakest part of your circuit is no longer this, which is easily accessible in a panel box. It's somewhere in the wall. And other ones, I found these in my basement, so I'm not sure how old they are. Here's another one that is 60 amp. This is a pretty big thing. It has like a pull out plug thing. So these were designed to be the part of the circuit that failed so that you could get to them. It just says pull fuses. Nowadays, it tends to be more of the circuit breakers, where when too much current is pulled, it flips a switch. That way you can just go back down and flip the switch back, and you don't have to have replacements of these. But same idea, the weakest part of the circuit that will break when too much current is drawn is something that we can get to readily. Now, electronics and electricity does go off and get more complicated than that, but this has sort of been just a very general quick look at what electronics is and kind of how it relates to the way your house is built. So if you know where that circuit breaker panel box is in your house, again, that's where, if things don't work, that's one thing to check, if maybe the breaker switch got tripped because someone tried to plug in a toaster, hair dryer, microwave, and washing machine at the same time. So anyways, hopefully you got something out of that. If you like this, let me know if you have other things that might be interesting for me to try to explain. Might fail at it, like that demo that just didn't work, but you know, they can't all be winners. Anyways, if you're one of my students, you do have a follow-up assignment to do. If you're not one of my students, hi.